Today we are going to learn about integrating using the chain rule. Prior knowledge is that you should already be able to integrate terms involving brackets. You should be able to work with fractional indices and also work with negative indices. Up until now, when we have had a function like 2x plus 1 all squared, to integrate we would have to prepare it by multiplying out the brackets first. But how do we integrate f of x equals 2x plus 1 all cubed? Multiplying out the brackets here could be very tedious. The chain rule also applies to integration, and you have already used it when you integrated sine and cos. The method is, if we have the integral of ax plus b to the power of n, we add 1 to the power n and divide by that power, but we then also divide by the number in front of x. Essentially what we're doing is we are integrating outside the bracket and multiplying by 1 over the derivative of the bracket or dividing by the derivative of the bracket. Example 1. We have to integrate x plus 4 to the power of 7. So if we write that down, and if we ignore the fact there's an x plus 4 inside the bracket, so I'm going to integrate outside this bracket first of all. So I'll add 1 to the power and divide by that power. So that'll be the bracket to the power of 8, all divided by 8. Inside the bracket we have x plus 4. So the derivative of that bracket would be 1. So we're multiplying by 1 over 1 and we need our plus c. Multiplying in, the denominator remains 8 and the final answer is x plus 4 to the power of 8 over 8 plus c. Example 2, we have to find the integral of 2x minus 1 all cubed. Again, we'll write this bracket down initially. Ignore what's in the bracket because we are integrating outside the bracket first. So it will become to the power of 4 over 4. Then we have a look at what's inside the bracket. So I'm really multiplying by 1 over the derivative of this bracket. Now the derivative of the bracket is 2. So I multiply by 1 over 2. Or you can think about it as also dividing by 2. We need to then simplify this expression by multiplying our 4 and our 2 together on the denominators to get a final answer of 2x minus 1 to the power of 4 all over 8 plus c. Example 3. Find the integral of 1 over the square root of 4x plus 3 with respect to x. So we first of all here have to prepare our integral because we cannot integrate a fraction. We don't get to that till advanced higher. So to prepare it, we've got the square root of the bracket on the bottom, which means the bracket has a power of a half. But what we'll do is we'll bring the bracket up and give it a negative power. So we're really integrating 4x plus 3 to the power of negative 1 half with respect to x. So firstly, we're going to integrate outside the bracket. Now negative 1 half plus 1 will give a power of positive a half, and then we'll divide by that power as well. So we'll have 4x plus 3 to the power of half divided by 1 half. We then need to multiply by 1 over the derivative of the bracket. Now the derivative of that bracket is 4, so we're multiplying by 1 over 4 and we have our plus c. Then we will need to multiply and tidy this expression up. So the top part of the fraction, we've got the number 1 times the bracket, so we'll just be left with 4x plus 3 to the power of a half. And on the bottom of the fraction, 1 half times 4, or a half of 4, is 2. And we have our plus c. Now, we shouldn't leave expressions with fractional powers. This is really important if we're inserting limits into our integral. So what we'll do is we'll change it from a power of half to the square root. So last line is the square root of 4x plus 3 all over 2 plus c. Now try these examples on your own. Please pause the video. And the answers are, for that first question there, 2x plus 3 to the power of 3 all over 6 plus c. And the second question, final answer would be 3 over 10 cubed root of 5x plus 9 squared plus c. So what have we learned today? Today we've had a look at integrating brackets with powers, and we're using the chain rule, where we integrate outside the bracket, but we multiply by 1 over the derivative of the bracket.